Dear students, myself Muhammad Bas. This is another lecture. So last class we have discussed about the analytic part of the rectifier. So last class we discussed about the half wave rectifier analysis part, right? So today we have to discussing about the next topic, that is right. So today we can discuss about the filter blocks. Before going to filters, I have to tell one small important thing. So in half wave rectifier analytic part, so how we have taken the analytic part for the IDC. So here we are taking the IDC means we are taking the 0 to pi only. Okay, pi to 2 pi we are considered as the 0 only for half wave rectifier. So I given the one work for you. So same thing you apply for the full wave rectifier also. For full wave rectifier, pi to 2 pi also you have to consider, right? So again remaining process is same thing, right? So like that you have to do analysis part of the full wave rectifier also, right? So last class we discussed about the different types of the rectifiers. So what is use of the rectifier? Here the output of rectifier we are getting only positive pulses, right? For half wave rectifier we are getting the alternate positive pulses. For full wave rectifier we are getting the continuous positive pulses only. But our main motto is we have to convert our available AC source into the constant DC source. Means generally available source is the AC, but we have to convert the DC only. But till now we have converted available source into the only positive peaks only. So right, so for this instant we have to convert our positive peaks to the constant DC. So that's why we have to use the filters. Coming to the filters, right? So I already told why we are using the filters, right? So filter is a block so which converts the pulsating DC to pure DC, that is called as a smoothing process. We are getting the only positive peaks. So here filter which converts the positive peaks into the smoothing, means constant DC. So here only rectifier which converts the only positive peaks. So with the then we have apply this rectifier output to the filters. Then the output of the filters we are getting the constant DC voltage. This is main introduction of the filters, right? Coming to the filters, why we are using the filters? Generally our available source is the AC source. AC consisting the positive peak and negative peak, right? So here this one we are applied to the rectifier. So any rectifier, so here we are taking the bridge rectifier. So bridge rectifier output we are getting the only positive pulses, right? For bridge rectifier we are getting the only positive pulses. But this positive is a not constant voltage. So we require this constant voltage. So that's why we have the another block in our RPS. So remind that. So another block is the filter block. So today we are discussing about the filter circuit. So how filters will be constructed? So how filters will be constructed? Generally for construction of the filters we have to use the passive components only. What are those passive components? Okay, generally resistors, capacitors and inductors. These three we are named as the passive components only. With the help of inductors and capacitors we will make the filter block diagrams. That's why filters are generally classified into 4 types. So right, filters also classified into 4 types. The first filter is series inductor filter, right? Series inductor filter. Why series? Right? I will tell in next session. So next, shunt capacitor filter. Shunt means a parallel capacitor filter. Why parallel? This one also I will tell in later session. So next one is LC filter. L stands for inductor and C stands for capacitor, right? LC filter, and last one is the pi filter. So generally filters are also classified into 4 types. So what are those 4 types? First one is in series inductor filter, and second one is shunt capacitor filter, and third one is LC filter, and fourth one is pi filter, right? Coming to the first filter, our first filter is inductor filter. So series inductor filter. Why we have to connect inductor in series, right? So the basic operation of inductor is inductor allows the DC and stops the AC, right? Remind it. So inductor allows the DC and stops the AC, right? So inductor, so this is the symbol of the inductor. So this allows the DC and it blocks the AC, right? It blocks the DC. That's why we are connecting the inductor in series, right? So before this we can connect any type of the rectifier circuit, right? Before this we have connect at any type of the rectifier circuit. So here I am connecting the one full wave rectifier, right? One full wave rectifier. What is full wave rectifier inputs? So here we are getting the only positive pulses. Only we are getting the positive pulses, right? These positive pulses consisting the AC as well as DC. So these things we are already analysis part also completed in last class. So here we are getting the IAC and IDC also. With the help of these two, we are, with the basic of these things, we are going for the series inductor filter, right? So here our input signal is, so here we have the our input signal is positive peaks, right? These are the positive peaks we have at the input side. So for inductor input we have the only positive peaks, right? So what is output? So here we are taking the outputs. So here what is output for filter? So inductor filter outputs we are getting the some constancy, but not straight, but some sort of constancy we are getting at the output side. So how this constancy will come? How this constancy will come means, so input of the filters we have the ripple component also, right? So here we have to know about the ripple factor also. So what is meant by ripple factor? Ripple factor is a AC by DC, right? AC by DC. So we have to eliminate the AC and we need the DC. That's why ripple factor as less as possible can be considerable, right? For that, so we are connecting the these inductor in series. Why this inductor we are connecting in series means, so inductor I already told you which stops the AC and which allows the only DC, right? So this positive peak is consisting the both AC and DC itself first, right? So it only allows the DC and which only stops the DC. Then we are getting the only DC at the output side, right? So how we can take this means, here what is the equation of the current? So here the current equation is 2 Im by root, sorry, here our current equation is 2 Im by pi, right? Our maximum current is 2 Im by pi. So here we are taking the, so I will tell you here again, right? So current equation is 2 Im by pi, right? So our input signal is only positive signal. This is maximum current Im, right? So here 2 Im by pi. Im by pi means, if we are taking some Im by pi means one line means, so inductor which allows this average DC at the output side. So it blocks the AC, right? Like this inductor work as a filter, right? This is the basic operation of the inductor filter, right? So here our current is 2 Im by pi, right? As per that, so we are getting the constant DC with the help of inductor filter, right? This is the basic operation of the inductor filter. Coming to the ripple factor expression. So we have to know about the ripple factor only. So all filters we are analyzing with the help of ripple factor only, right? So what is ripple factor, right? Ripple factor is generally we are denoted as a AC by DC, right? So AC by DC, right? So we need the DC component, so we have to reduce the AC component. So okay, general expression for the ripple factor here. So here ripple factor expression is, so we can apply some basic analysis. Then we are getting the ripple factor for the inductor filter is RL divided by 3 root 2 omega L, right? So RL 3 root 2 omega L. So here L stands for the inductance, right? L stands for the inductance. When we are increasing the inductance value, then only our ripple factor is going to the reducers, right? So for this we have to know about the two types of operations. So the first operation is in case of load resistance is infinite, right? For example, RL value, load resistance value is infinite. At this case, what happened? Then we are applying some analysis for the inductor filter means then we are getting the ripple factor of the 0.471, right? 0.471 also very less amount only, right? If we are applying some sort of load value means we are getting the 0.482. So here we have to learn about it is clear that inductor filter should be, right? So it is clear that inductor filter should be used only where RL is consistently small, right? Consistently small. Why? Because when I am increasing the RL means what happened? Again ripple factor may goes to the increases. Why? Because ripple factor is directly proportional to the RL, right? So that's why. So RL must be in small only. So here load resistance we have to use the small value of the resistance only. Then this is the good amount of filter, right? Okay, due to this advantage, we are going for the next type of the filter, that is named as the capacitor filter. Another name is the shunt capacitor filter. Shunt means parallel capacitor filter. So here this one is the basic block diagram of the rectifier. This is which rectifier? This is the half wave rectifier. This one is the half wave rectifier. So here input is also sine wave, positive peak and negative peak. So here we are getting the only positive peak only, right? If I am taking another positive and negative peak itself, we are getting alternate positive peak only. Negative peak is going to the suppressor at the output side, right? So at the output side, we are connecting the one capacitor, parallel capacitor. Means here capacitor is connected as a parallel. That's why this filter we are named as the shunt capacitor filter. Shunt means parallel capacitor filter. So what happened with the capacitor, right? So this is the reverse operation of the inductor. So inductor which stops the AC and which allows the DC. That's why we are connecting inductor in series. This is the reverse operation. Capacitor is the reverse operation, right? So capacitor allows the AC and which stops the DC. Means which allows the AC means we does not require any AC component. That's why we are connecting in parallel. So all AC is going to the grounded. AC component is going to the grounded. Only DC component is stopped, means capacitor does not allows the DC component. So here we are getting the only DC component. So output we are getting the only DC component. Why? Because capacitor does not allow the DC, which allows only AC, right? So we can explain these things with the help of peaks, right? Here we have the output side. So generally diode out means transformer output side we have the sine wave. So here we have the positive peak and negative peak. At diode output we are having only positive peak only at the time of positive peak. So what happened at the time of positive peak? So capacitor, again another important point is capacitor does not allows the sudden change, right? Capacitor does not allows the sudden change, right? Right? So for the amount of the positive peak, so capacitor is going to the charging, right? That's why this arrow marks is coming like this, right? For the positive peak, capacitor is going to the charging. Right. Here we does not having the another peak continuously. So here we have some gap. Another some instance we have the another positive peak, right? So at this here we does not having any peak, right? At this time. So without having the positive peak, then what happened? So it does not able to charge maximally. Then capacitor is going to the discharge. So the capacitor is going to the discharge like this, right? So here we have to learn about the two things. One is the charging of the capacitor and second one is the discharging of the capacitance. How capacitor will charge means at the time of positive pulse, capacitor is going to the charging, right? So half wave rectifier with capacitor, positive half cycle, right? For positive half cycle, capacitor is going to the charges. For the negative half cycle, capacitor going to the discharged along with the load resistance, right? This is the basic operation of the capacitance, right? And next we will see the how capacitor act as a filter, right? So here we have the input of the capacitor filter. Generally here we have the only positive peaks only, right? So here we have the only positive peaks only. How these positive peaks converted into the pure DC? So how smoothing will be occurred with the help of capacitive filter? We will see. Right? For the positive peak, so I already told you at the time of positive peak, capacitor is going to the charges, right? So at maximum, right? So up to here at maximum voltage. So at maximum voltage, capacitor is going to the charges. From positive to here, our positive peak is going to the decreasing, right? Here our positive peak is going to the decreasing, right? Then positive peak is going to decreasing means capacitor is going to the discharge, right? Capacitor is going to the discharge. So here up to maximum voltage, capacitor is going to the charge. So when positive peak is going down, right? Here positive peak is going down means capacitor is going to the discharge. How it will be discharged means depends upon the RL value, load resistance value. So it will be slowly discharged. So at how much time it will be discharged means again positive peak will be come, again capacitor will be charged, right? Again capacitor will be charged when again positive peak is going to the negative and again capacitor is going to the discharge, right? So what is here? What is output for this? What is output for this capacitive filter only? So here we are getting the charging, discharging, charging and discharging. So here we are getting the output as a smoother compared to the positive peaks, right? Rectifier output is positive peaks, but here we are compared to these positive peaks, we are getting the smooth type of the DC signal, right? So this is the basic operation of the shunt capacitor filter. Right, coming to the same shunt capacitor filter for the full wave rectifier, right? So last slide we discussed about the shunt capacitor filter for the half wave rectifier, right? So how capacitor will be charges and discharges, and how our positive peaks are coming as a smoothing, means coming as a straight signals, right? Similarly, we can discuss same thing for the full wave rectifier, right? So what is this circuit? All of you know this circuit. What is this circuit? This is the basic circuit diagram of the full wave rectifier, right? So here simply we are placing one capacitor parallelly, right? Here simply we are placing capacitor parallelly, right? So how it will be works, right? Generally, what is output for the full wave rectifier? Full wave rectifier, continuously we are getting only positive peaks only, right? For full wave rectifier, we are getting continuously positive peaks, right? For these positive peaks, how capacitor will be work? We will see in next step, right? So coming to the full wave rectifier for the shunt capacitive filter. This is the input of the input positive peak for the shunt capacitor filter, means full wave rectifier output. So at this time, so here also capacitor, okay, capacitor basic working is capacitor, okay, allows the AC and which blocks the DC, right? So at the time of positive peak, means at the time of positive peak means at the time of maximum peak, so capacitor is going to the charges, right? It going to the charges, okay? After that, capacitor is going to the discharges, right? Again, next to positive peak is coming at similar output. At this point, again capacitor is going to the charges, right? So again here capacitor, when this positive peak is going to the downwards, means it decreasing, means again capacitor is going to the discharges, right? So this discharging point means then when available point, right? Then when positive peak voltage, this maximum voltage point and this discharging point both are equal, then again capacitor is going to the charges and again capacitor is going to the discharge. Again capacitor charge and again capacitor going to the discharge. So how pulses will coming here? So here we are coming the pulses, right? So compared to the half wave rectifier, right? For full wave rectifier, we are getting the again more constant amount of the DC we can get with the help of shunt capacitor filter, right? So coming to the bridge rectifier. So bridge rectifier also same operation, right? Why I am telling bridge rectifier also same operation means for bridge rectifier output also we are getting the only positive peaks only. So here also capacitor is going to charging and discharging, charging and discharging continuously itself, right? So here also we are getting same thing, right? So for full wave rectifier shunt capacitor and bridge rectifier shunt capacitor, the working is the similarly, right? Coming to the ripple factor, right? So every filter we are discussing with the help of ripple factor, right? So then what is meant by ripple factor? I told you, AC by DC components, right? Ripple factor as less as possible considerable, right? Here the ripple factor value is 1 by 4 square root of 3 F C R L, right? Here C stands for the capacitance and RL is the load resistance. Then what happened? The ripple factor may be decreased by the increasing CRRL, right? Here we are increasing the capacitance also, ripple factor is going to the decreases. When RL, when we are increasing the RL also, ripple factor is going to the decrease. But what happened with inductor filter? So here for inductor filter, ripple factor is directly proportional to, right? Ripple factor is directly proportional to, right? Ripple factor is directly proportional to the RL. When RL is increases means the ripple factor also increases, right? At this time, so for inductive filters we have to use the less amount of the load resistance, but here that is not necessary, right? So here we can increase the load resistance, means then automatically ripple factor may goes to the very less value, right? That's why, because this is the inversely proportional to the load resistance as well as capacitor, right? That's why in practical manner also we are using the shunt capacitor filters itself, right? So in practical circuits also we are using the shunt capacitor filters only, right? This is the one of the important filter, right? Why? Because in any charger circuit and any laptop charger, mobile charger, any charging, any adapter, means any RPS, we are using the shunt capacitor filter only. Why? Because coming to the inductor means, so inductor if we are placing on the circuit board means it will be larger and means some sort of cost also very high. That's why we are using only shunt capacitor filter in practical also, right? In our experiments also we are doing with the same thing, right? Shunt capacitance, with the help of shunt capacitance only we are calculating the ripple factor and we are observing the how pulsating DC is converting the pure DC. Coming to the another type of filter, right? So general things that theoretically we have to know about the again different types of the filter. Again next type of filter is the L section filter. Then what is meant by L section filter means here one inductor and one capacitor, right? This is one inductor and one capacitor, right? This is the reverse L shape. That's why this is named as the L section filter, right? So for this filter we are using the one inductor and one capacitor also, right? Why inductor is connecting seriously? Anyone? Right? So I already told you, inductor which stops the AC and only allows the DC, right? Why capacitor is going to connecting in parallelly? Capacitor which allows the AC and which stops the DC. That's why we are connecting inductor in series and capacitor in parallel, right? So the shape is the L shape. That's why this filter we are named as the L section filter, right? So coming to the L section filter operation itself. So here also we have the one inductor itself. So we are getting the maximum DC only, right? Maximum DC point only. So at parallelly we are connecting the capacitance. Why parallelly capacitance? Means the output is depends upon the load resistance. So here we have to consider about the load resistance. If I am using only single inductor filter means we have to use very low value of the load resistance. If I am using the parallel capacitor means okay, capacitor means load resistance. It depends upon, we can use vary the load resistance as high as possible. That is depends upon the our consideration, right? That's why we are using the this type of the filter. Right? So coming to the same full wave rectifier with the L section filter. So any rectifier, any type of the rectifier, we are connecting the L section at the output side only. So here also we are connecting one inductor and one capacitor in L shape only, right? So like that we are connecting, right? For full wave rectifier also we are connecting similarly. So here also we are getting the same type of the output, but so for half wave rectifier we are getting the alternate positive peaks. So here alternate positive peak, but full wave rectifier we are getting the continuous positive peak. Only this is the difference. Coming to the ripple factor. Here coming to the ripple factor means so here ripple factor is 1 by 6 root 2 omega square L into C. L stands for inductor and C stands for capacitor. So here can you observe, here load dependency is not there, right? Here load dependency is not there. So that whole ripple factor is depends upon the inductance and capacitance only. So both we can increase means ripple factor may goes to the decreases. This is the main advantage of the L section filter. Right? Advantages. Advantages of L section filter means LC filter or else L section filter. L stands for inductor, C stands for capacitor. So what is the main advantage means? So I already told you, right? In choke input filter. So choke also we are named as the inductor only. So choke input filter. So here input we are connecting the inductor. That's why. So in choke input filter, current flows continuously. Therefore, the transformer is used more efficiently. But for capacitor means it charges and discharges. Transformer not utilizing continuous. If we are using continuously means in series as a inductive means here continuously current flowing means here we can utilize the transformer continuously. Here we are utilizing transformer continuously means the TUF, transformer utilization factor, also increases. This is the one of the advantage. Okay, next coming to the ripples. So automatically ripple factor, that is depends upon the L and C. So when we are increasing L value and C value means then automatically ripple factor may goes to the decrease. That's why LC is inversely proportional to the ripple factor. So coming to the less dependent